Hello, welcome to the Chemistry Made Sense series. Today we're going to look at one advanced dimensional analysis problem. It is more advanced because we are using multiple conversion factors in the calculation to get the final answer. But don't let the word advanced scare you. Once you understand the basic principles of dimensional analysis, even problems like this become completely manageable and make perfect sense. Here's a question. Suppose you have Avogadro's number 6.02 times 10 to the 23rd of dollars, which is apparently impossible. Now, if you spend the money at a rate of $1 billion per second, how many years it will take you to spend all the money? First, let's identify where we are and where we want to go. We start with dollars. We want to end with years. To get there, we need several conversion factors. We need to convert dollars to seconds, then seconds to minutes, then minutes to hours, then hours to days, and finally days to years. Please pay attention that every conversion factor is like a bridge between two units. As we multiply them together, the odd units or the undesired units cancel out one by one until we end up with years. Now, let's do this together. We multiply 6.02 times 10 to the 23rd dollars by the first conversion factor, which is 1 second, over 1 billion, which is 10 to the 9th dollars. In this case, we can cancel out the dollars to end up with seconds. Then we convert the seconds into minutes by multiplying the second conversion factor, which is 1 minute, over 60 seconds. So we can cancel out the seconds to end up with minutes. Then we convert minutes into hours by multiplying the third conversion factor, which is 1 hour over 60 minutes. So we can cancel out the minutes to give us hours. Then we convert hours to days by multiplying the fourth conversion factor, which is 1 day over 24 hours. So we can cancel out hours to give us days. And then we multiply the fifth conversion factor, which is 1 year over 365 days. So we can cancel out the days to end up with the year, the final new unit. After that, we do the calculation on the numbers, we can end up with 1.91 times 10 to the 7th years, which is also about 19 million years. Amazing! This tells us how huge Avogadro's number is. More importantly, notice that this advanced-looking problem was solved using exactly the same principles we learned in the earlier videos. Once you understand the basics, dimensional analysis becomes a powerful and logical problem-solving tool. In our next videos, we're gonna move forward to explore the mole concept. You will soon discover that a mole is simply a counting unit based on Avogadro's number. 6.02 times 10 to the 23rd. Understanding the connection between these two ideas opens the door to many chemistry calculations, and dimensional analysis remains as one of the most important and powerful problem-solving tools. Thank you for watching. Please follow ChemExcel for chemistry that really makes sense.